Okay, inserting a new node at the middle of the list. In the previous video, we have discussed about how to insert a new node at the end of the list, and for every insertion we need few things. That we need to have the structure of a node, which I have already declared here, and we will be creating one function that inserting at mid, which will be receiving one data. Okay, and then we need to create a new node. So this is a normal procedure for every insertion algorithm. Okay, so let's say we will be receiving one data. This line will be creating a new node. The temporary, we have created one address 500. The name of that address is suppose temporary, and this is your information field. This will be your next field, and to the information field of temporary you assign your data. Let us assume that that data is 55 and the next field is null. So you created the new node, fine, but you have to check one condition every time, that if there is existing list is not available. So how will you check it? In the previous two videos we have seen that if start is equals to null, it means that we do not have a list. Okay, and then we'll be assigning start is equals to temp, means the temporary node itself is our starting point. There is no need to produce any other list. So this will be your first node which will be starting itself when you do not have any existing list. Okay, else it means that you have a existing list. Okay, let's say we have a existing list. So I'll take some random data like 22, 82 and suppose 17, and every block will be having some address, suppose 700, this will be having address 200, and this will be having suppose address 400. Random addresses we are taking for the better understanding. It is 200 which is pointing to the next element, and this will be a 400 which will be pointing to the next element, and this will be your last node, and this is your starting point. Now the good thing is we want to insert this new node at the middle of the list, and we have a existing list now. That's why we are in the else part. Okay, now let us assume that you want to add this new node at the middle of the existing list, suppose here. But there are two different locations where you can add the list, after 22 or after 82. So you are not able to fix it. So you need to fix it first, where exactly you want to insert this new node, middle of the list, but where? So that information will also be provided by the user to us. So what you need to do, you need to make one change here, and what that change is? That change is you need to take one more argument to this function, that is integer position. So after which element you want to insert, that value you will be taking into this variable called POS, that is position variable. I have named it as. Okay, now for understanding, let's say I'll be writing this list again as it is 22, then 82, and this is your 17. And in the current scenario, it is pointing to this and it is pointing to this. The address of 22 is 700, it is 200, it is 400. Okay, here I need to write 200, here I need to write 400, and this will be your null. Okay, and this is your starting point. So what we want to do, we want to insert our new node. Inside that new node we have a value for 55, the next field is null, the address which we got for this is 500, and name for this is temporary. Okay, so we want this node suppose here in between the 82 and 17. So what we'll do, data which you got is suppose 55, which you have already inserted into new node. Okay, and the position is you got suppose 82. So what it means, you want to insert this new node 55 after 82, means here somewhere it will come. Okay, so what you need to do, you need to identify where is the 82, what is the address of 82. Suppose you are able to point it, so you will be mark it as, suppose this is 82, you found it into the list. Okay, after 82 you want to connect with the 55, means here instead of 400 you will be writing 500, and after temporary you need to point out to this 400, means like this, correct, and this connection will be broken then. So to make all these changes we need to write some different logic. First task is to find out where is the 82. Okay, we'll be writing where is the 82, and how will you know that in which section you will get 82? You will get a 82 in the information section, because this is the section which is containing your information. So you need to traverse a entire list. You need to start from the first node. You will be checking the information whether it is 82, no, go forward, whether it is 82, yes it is 82, stop there. Okay, so how will you start? In the previous video we have seen that you can traverse a list with the help of additional pointer. So I'll be taking that pointer P and I'll be assigning a address of starting to the P. So this is your P, because start will not leave his place. So I have taken additional pointer P. So we'll be check P's info, that is 22, is equals to the POS, that is 82, no, then go forward. So how will you write here? You have to write while P's info is not is equals to POS. Okay, then what you will do, P is equals to P of next. This is the logic to find out the given number. So let's say what is POS? It is 82. What is current P of info? P's info is 22. Okay, which is not equal. Go inside. What is P of next? P of next is 200. Copy it into P. So what is the new value of P? P will be 200. So it is pointing to 200 now. Come back to the loop. What is P's info currently? P's info is 82. Okay, POS is 82, but we don't want not equals to. But we want not equals to, so it's a false condition. So P is pointing to the 82 now. Okay, fine. But after P we want temp, and after temp we want 400, but we don't have a 400 value in any variable. Okay, we need to copy this value 400 in some variable. So what I'll do after the loop, when I find the 82, when I found 82, what I'll do, I'll write Q is equals to P. Q will be my another pointer. Q is equals to P of next. Try to understand this. We found 82 on P by traversing. Okay. P of next, that is 400, you are copying to Q. So 400 will be copied in Q. Correct? Okay. And now what you will be writing? After P you want temporary. Okay, so you will be writing P of next is equals to temporary. P of next is temporary. So P of next is will not be a 400, means it is not pointing to this node anymore. It will be pointing to the temporary, that is 500. So it is pointing to this node, that is 500. Okay, and now temporary will point to the Q. So what is the address of Q? It is 400. So here you will be writing 400, and this will be automatically connected to the next node. So how we have to write it? Temporary's next should be your Q, and then you're closing your else and then closing your function. Look, so P of next is temporary, P of next is temporary, and temporary's next is Q. And why we need this line Q is equals to P of next? To get the address of next node after the discontinuity of that node according to the previous node. You have to remember that address. So we have already copied it into Q and we were using that. So this is how you can insert a new node at the middle of the list after a particular node. And you can see from the diagram, after 82 we have successfully inserted 55, and after 52 you can access the 17. So this is insertion at the middle of the list. So let us write a code for this. So we have already written the code for insert at end. So let us create another function here. I'll be creating that insert at mid. Okay, there will be a confusion that I have using inserting at mid in the algorithm, and here I am using insert at mid. So don't be get confused. So I'll be using insert at mid. Here you will be receiving one data as well as you will be receiving one position variable. Then the very first task, as always, is we need to create a new node. So we'll be calling to create a new node for the given data. Then we'll be checking that whether the list is available or not. So how will you check it? If start is equals to null, what will happen? You will be writing start is equals to null, so start is equals to temp. That is, your new node will be the starting point. Else, if this is not the case, then you will start from P. So starting address given to the P, and you will search for a particular position, because after that we want to insert our new node. Okay, so you will be writing while P of info is not is equals to given position element, till then P is equals to P of next. Keep moving P to the next location. When you found that element, P will be stopped. Okay, and after that the next element of the P, that is Q, has to be created. So Q is equals to, it's a P of next, so it's a old P of next. So in the previous list, suppose this is P82, P of next is 400, so you are copying it into Q. So you need to declare this Q variable. So here I will be declaring that variable, comma, Q is equals to null. Then only we can use that. So Q is equals to P of next. Okay, then P of next is temporary and temporary is next is Q. So we need to create this connection. So you will be writing P of next is equals to temporary, that is new node, and after the new node, that is temp dot next is equals to, you will be adding Q. Okay, but there is one issue with this. What if POS is not found? How will you check it? So inside this while statement, you have to write one logic. If you are searching for a particular element, for example, user has given some value that is 100, which is not there in the list, it will check P match, no match, P will be here, no match, P will be here, no match, P will be here, no match, P will be to the null. So if you are not getting that element, so you have to check that condition. If P is equals to null, if you are moving forward, and when P itself gets a null, then you will be returning, you will be not doing anything, you will be getting back to the calling function. So this is the logic to check whether the given position is available in the list or not. So if not, then it will go back, it will return back to the calling function. So this is the code which we have written for the insertion of the new node at the middle of the list. And now we completed with the insertion at beginning, insertion at the end, and insertion at the mid. So let us try to write a code for displaying this. So we need to traverse each node. So I'll directly writing here, after this function I'll be creating another function, that is display. Okay, the task of the display is to display all the elements. Fine. So what you need to do, you need to start from somewhere. So we'll check whether the list is available or not. So how will you check it? If start is equals to null, means if it is null, we don't have anything to display. So you will be writing that list is empty. You will be displaying that message, list is empty, and you will go back. So return. Else, if it is not the case, then you need to visit all the elements and you have to display all the values till the next field of any node should be null. So what will happen? You will print 22, 82, 55, 17, and then how will you know that this is the end of the list? Again, you need to check whether the next field of any node is null, then that is my last value. So we have done it for insertion at the end. So simply you need to write p is equals to start, then while p is not is equals to null till p becomes not equals to null, what you will do, you will be printing values, that from p's information section. Okay, and to print this horizontally, I will be writing this only print function so that you will get your elements horizontally, and to add the space in between I will be add it manually so that you will get a space between every element. Okay, and after printing that element, move your p to the next element. So what will happen? P is equals to start. P is not null because P is containing value, suppose 700. So it will come inside. It will print the piece of info, that is 22. It will be printed. Okay, it will go piece next to the P. So this will be your new P. Then it will print 82. Okay, then it will check 200. 200 is not null, so it is printing 82. P of next to the P, that is P of next is 55, so P will be here. Okay, then that address is 500, so 500 is not null. Okay, so that 500's information will be printed, that is 55 will be printed. Okay, then P of next will be copied into P, so this becomes your P. P's info will be printed. Again P of next will be copied into P, so P of next is null, so next P will be your null, and this loop will check whether it is null. Yes, so it will stop that loop, and this is how you will be printing your list. And now we want to use it. So how will you use it? So inside the main function you need to call your respective functions. So let's say we will be calling the same list, that is 22, 82, 55 and 17. So we'll be creating that. So everything which we have written, all the operations in the SSL operations. So here you need to create an object in SSL operation. So SLL operations class, its object is equals to new SLL operations. Okay, this will be our main method. Then through this object OP, we will be calling functions. Suppose insertion at beginning, I will be sending one value, suppose 45. Then I will be calling OP dot insert at the end. After 45, add some value, suppose 76. Okay, will be after 22. I want to insert at the end, so I will be keeping the same values, that is 22, suppose 17 at the end. Okay, then op dot insert at mid, and in between 22 and 17, suppose I want to add, okay, I want to add 88, 82, sorry, 82 after 22. So position will be after 22. Then again I will be inserting any element dot at the mid, and I want to insert that element after 82. Sorry, the new value is 55 and after 82. So we'll be using all the functions here. So you called insert at the beginning 22, insert at the end 17, insert at the mid after 22 82, so it becomes 22 82 17, and 55 after 82. So it should print exactly the same list which we have corrected here now. So let us call our display function, so op dot display. And before this I would like to print one message that singly linked list is, and it should print that list. So let us run it. I will be running it manually. So I will be writing java c demo sll dot java, and then I will be writing java demo sll and hit enter. So you will be getting your message that singly linked list is 22, 82, 55 and 17. 22, 82, 55 and 17. So our operations are working exactly the same. Now let us try one more combination. Suppose I want at the end of the list. So I'll be calling op dot insert at the end and let us add 99. Okay, and let us try to compile it again and display. So you will be see that we have successfully added 99 after the 17. Okay, let us try one more operation, that insertion at the beginning, and write the element suppose 34. It should be inserted at the beginning and we are then calling the display function. So compile it and run it again. So you will get that 34 is inserted at the beginning of the list. So we have successfully implemented all the insertion operations on the singly linked list. So the next video will be on deletion from the singly linked list.